All right, so what I want you guys to be able to make sure that you can do is following those rules that I discussed in the notes. Can you actually give me those 4 things that I wanted? Can you give me the orbital diagram? Can you write an electron configuration and be able to tell how many unpaired, how many valence electrons there are? So what I want you to do is I want you to actually pause my video right now, and I want you to try to write those 4 parts for magnesium. And if you look it up, magnesium is number 12 on the periodic table. So I'm gonna go ahead and work it right now, but I want you to pause it, and then I want you to start my video back up and see if you can actually do it. Okay? So again, following all 3 rules: Pauli exclusion, off-ball principle, Hund's rule. Here's how this goes. The 1s orbital gets filled first. So I'm gonna have 1s. It can have 2 electrons in it. Then I move to 2s, and it's gonna have 2 electrons in it. Then I would move to a 2p orbital. That's the next lowest energy. Remember, p orbitals, 3 orbitals that make it up. So I've got 4 right now. This would be 5, 6, 7, 8, 9, 10. So if you look at the notes and the previous information that I've given you, the next lowest energy level or the next level orbital that's filled is 3s. I'm at 10 electrons, and s orbital can hold 2 electrons. So there is the orbital diagram for magnesium. Hopefully you got it right. So short form, I would say 1s, there's 2 electrons in it. 2s, there's 2 electrons in it. 2p, there's 2, 4, 6 electrons in it. And then 3s has 2 electrons in it. Remember these numbers, so that's 4 plus 6 is 10 plus 2 is 12, should always add up to your number of electrons that you're doing. So then unpaired, well, all of these are paired up. Your unpaired is always going to be at the end because it's going to be that last orbital that's filled. That's kind of showing you how many are unpaired, but those are paired up in that 3s orbital. So this guy has 0 unpaired electrons. Valence. Valence is where are your electrons in the outermost energy level. So think rings. So level 1, level 2, level 3. So again, I have electrons in level 1, but I also have electrons in level 2, but I've also got electrons in this level 3, and they're in an s orbital, and there's 2 of them. And if you look, magnesium is in group 2, so it should have 2 valence. So there is your correct answer for that. I hope you guys got it right. So now in the notes, there's one problem that I want you to also kind of work. So if you want to pause me, work through this problem, make sure that you actually get it right. So I'm going to go ahead and work it with you. So phosphorus, we're looking at an atomic number of 15. So again, what I've got to do is I've got to look at, okay, I've got to make sure I have room here. I've got a 1s orbital. Start with 1s. It's going to have 2 electrons in it. My 2s orbital, there's going to be 2 electrons in it. That's 4. Then I've got to move to a 2p. Well, anytime I have a p, no matter what level, there's 3 orbitals that make it up. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I've got 5 more electrons to place. So the next level that's filled, if you look at your notes, is 3s. That's going to be 12. So the next level after 3s, if you're reading that periodic table like a book, you just kind of read straight across, and the next orbital that fills is 3p. So again, p orbitals, 3 lines. So I'm at 12 electrons right now, and remember, Hund's rule is you got to put 1 in each one before you go back and pair them up. So I would say 13, 14, and 15. So short form, that was the orbital diagram. Short form is going to be 1s has 2 electrons. 2s has 2 electrons. 2p has 6 electrons. 3s has 2 electrons. And 3p has 3 electrons. Now, unpaired, well, remember, they're going to be paired up all the way until the very end. So now I'm looking at these guys right here. Those 3 electrons, those 3 arrows are my 3 unpaired electrons. And then my valence, well, remember, it's highest level, and I'm thinking rings. So I have electrons in level 1. I also have electrons in level 2, but I've got these guys in 3s and 3p. Those are both in the outermost level is 3. I've got to add those together. So I've got to take these 2 electrons and add them together with those 3. So it has 5 valence electrons. All right, so I'm going to do 2 more problems with you. And if you want, what you can do is just pause me, try to see if you can get them. The first one I'm going to do is calcium. Calcium is number 20 on the periodic table, so we got to figure out where those 20 electrons are. And then I'm going to kind of show you on these two problems how to do an abbreviated electron configuration. Some of you guys might already know. If not, I want to show you there is an easier way than writing all of this out. We are going to do arrows for a day or two, and then I'm going to move to where we're just writing an electron configuration like this. And I'm going to show you an even easier way with calcium in the next one I do to kind of show you how to abbreviate. So for calcium, again, I've got to start with 1s. There would be 2 electrons. Then I would move to 2s. Again, 2 electrons. I'm at 4. Then I need to move to a 2p. I'm at 5, 6, 7, 8, 9, 10. And then I need to move to 3s. There's 11, 12. Then I need to move to 3p. This would be 13, 14, 15, 16, 17, 18. Then, if you look at your periodic table, the next one that's filled is not 3D. The next orbital that has the lowest energy after 3p is actually 4s. And if you look at calcium, it's in the 4s box on that periodic table that I kind of showed you. So 4s, again, I'm at 18. This would be 19, and that would be 20. So there's the orbital diagram for calcium. So what I would have to do here is I would have to write the short form. So I'm going to say 1s, 2. 2s has 2. 2p has 6. 3s has 2. 3p has 6. And 4s has 2. Now, if you want to write this as an abbreviated electron configuration, what you have to do, and I'm going to bring this periodic table back, what you have to do is use one of the elements from group 18. So one of these noble gases is all you can use. So if I find the noble gas electron configuration that ends in 18, it's right here. That electron configuration that would be the electron configuration or the short form for argon. So instead of writing all of that, I can put argon in brackets. But again, you can only use a noble gas from the row before it. So it would be argon 4s2. So I'm saying those 18 electrons plus those 2 more. If you don't understand this, there is no reason that you have to do this. Continue doing it this way if you're confused, and we can figure it out later, or just continue to write it like this. Okay, unpaired. This guy has 0 unpaired all the way until the very end. They're paired up. So those have no unpaired electrons. Valence, okay, I've got electrons in level 1. I've got them in level 2. I've got them in level 3. This is my highest level though. Level 4 is my highest level, and there's 2 electrons in there. So calcium has 2 valence electrons. All right, now I may have to do this in 2 rows because I don't think my video is going to be wide enough, but the next one I'm going to do is bromine. Bromine is number 35 on the periodic table. So I'm going to be placing these 35 electrons. And then after this video, you're actually going to have some practice problems that I'm going to give you to try to work some of these out and make sure that you understand how to do these electron configurations, meaning all 4 parts: orbital diagram, short form, unpaired, and valence. Okay, so again, first one filled is 1s. There would be 2 electrons. I'm going to try to fit all of this on the screen. I don't know if it's going to work. And then the next one that's filled is 2s. That's only 4. I got to go all the way to 35. Then I go to 2p. So that would be 5, 6, 7, 8, 9, and 10. And then again, next one is 3s. That would be 11 and 12. Next one, 3p. There's 13, 14, 15, 16, 17, and then 18. And then again, my next one, even with calcium up there, was 4s, gets filled. There's 19, and there's 20. Okay, so I'm going to try to keep going across and moving my thing across. So after 4s, if you look again, if you're checking out this periodic table, after 4s, the next orbital that gets filled is 3d. Okay, so the next one I'm going to put is 3d. Now, we haven't done a d orbital yet, but if you look back in your notes, d orbitals don't have 3, they don't have 1 line, they actually had 5 lines, and they could hold 10 electrons in them. So there's my 3d orbital. So I'm at 20 electrons right now. So there's 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So my 3D orbital is filled, but I'm only at 30 electrons and bromine has 35. So the next one that I go to after 3D, it tells me it's 4p. Again, I'm just reading right to left and it'll tell me exactly how they fill. So my next orbital is 4p. And again, it's a p orbital, so same thing, I'm gonna have 3 lines. 1, 2, 3. I'm at 30, this would be 31, 32, 33, 34, and 35. So there is the orbital diagram for bromine. Again, that's going to be a lot. Oops, I even dropped my pencil. It's going to be a lot when I'm writing my short form. So I'm going to go back here. Short form. 1s has 2 electrons in it. 2s has 2 electrons in it. 2p has 6 electrons in it. 3s has 2 electrons in it. 3p has 6 electrons. 4s has 2 electrons. 3d has 10 electrons. And then 4p has 5 electrons in it. So this should add up 4, 10, 12, 18, 20, 30, 35 electrons. But again, if you want to look at this, the noble gas that comes before bromine, so bromine is sitting right here. The noble gas, not the one that comes after it, the one that comes before it, is still argon. This is still argon at 18, I think. Yes, it's still argon. So we're going to have to say argon, which is this right here. It's this piece right here. So instead of writing all of that, I'm going to say argon, and then I'm going to go to the next row. I would go to the next row and say, well, here's argon, and I'd go to the next row and fill everything leading up to the element that I'm doing. That's how you do abbreviated. So it would be argon, and then 4s2, 3d10, and 4p5. That would be the abbreviated. So again, I still have to answer all 4 parts here. So I need you to be able to do the arrows. I need you to be able to do this short form. If you want to do abbreviated, you can. If not, don't worry about it. And then you have to be able to tell me how many unpaired and how many valence. So this is the only unpaired electron all the way at the very end. So 1 unpaired. Now, valence. This is where valence can kind of be tricky. I've got electrons way over here in level 1. I've got them in level 2. I've got them in level 3 right here, here, and here. But then again, my highest level is level 4, and there's some in a 4s, and there's some in a 4p orbital. So I've got to add those 2 with these 5 to get 7 valence for bromine. So again, this is how you do the electron configuration. And this is, I forgot to say in the other video, this is if you were doing them in ground state, as if they're not gaining any energy. So you're going to hear terms like ground state or excited state. This is just ground state. They're not gaining any energy at this point. So hopefully this helped, and hopefully you can work on the practice problems that I'm going to assign you. Thanks.